Okay, yeah, my name is Andreas Erdmann. I'm here from the Fraunhofer IISB in Erlangen. We are working on the modeling of lithography and optical effects, and this is also our direction, what we are doing then in Fabulous. Our background is more on lithography process for semiconductor fabrication, where we use then really light to pattern, create patterns for semiconductor circuits. And what we try to do is to translate some of this knowledge, what we have from the semiconductor fabrication to the world of fabrication of metasurfaces. Of course, there we use some slightly different techniques. We are using then this two-photon writing, so we had some former PhD student working a little bit on that, but here we will go deeper and then also understand more about the design of the metasurface and really bringing these two worlds together. Yeah, I think for the fabrication of optical metasurfaces, this approach really to model and the fabrication process and bring design together, this has not been done before. That is in the first step, similar to microlithography that was 30, 40 years ago. Then people tried to model really what happens during the fabrication and then improve fabrication. And of course, in the world then of metasurface, there was a lot of research in the past, try and error, try out a lot of interesting things. There were also modeling activities, but really then to bring things together, bring people together who understand something about the processing, understand something about the design, what needs to be fabricated. I think that is really the new thing, and that really can bring out a lot of innovation and new ideas into the field. Our background is more on semiconductor fabrication. Actually, we are working at the moment then on EUV lithography, lithography using extreme ultraviolet light to generate the latest generation of chips. And there we are working on how to design masks. Also, as the question, how far can you go with this technology? And now with the Fabulous project, we are coming to asking similar questions. And also when we want to fabricate then the optical metasurface, how far can we go with two-photon writing? Where are tolerances and what can we do? And surprisingly, in some of the things are also there are similarities. For example, when you look at the impacts of the bandwidth, I mean, usually when one simulates a system, one assumes monochromatic light. You have strictly only one wavelength. But this is not true in reality. Even in EUV, you have a certain bandwidth. And also in Fabulous, when we are using femtosecond pulses, of course, we have much larger bandwidth, and we can partly even exploit this for special parallel writing strategies. And there are interesting parallel things how to handle these effects, both in EUV and the wavelength range of 13 nanometer, and then for the range of long wavelength, more than 500 nanometers, than for Fabulous. I think the nice thing, or what I like so much, is really this options what you have now doing optics or in new way with this metamaterials. I mean, in the past you have done you have developed large lenses to do imaging. Now with metasurfaces you can do imaging with much smaller optical components, and you have really exciting opportunities. And On the other hand, even things what we learned then in Fabulous now, people even try to make meta lenses for EUV lithography. There were first papers beginning of this year, and I've just seen this, how people fabricate meta lenses for EUV, and I think there are a lot of exciting developments to be expected in the coming years. I would expect that we will learn a lot of things during the Fabulous, really, and that's the first time I think that we are in Fabulous really trying to address this meta service both from the design perspective, from a pure design perspective, from the fabrication perspective, and from the end user, really to bringing these three things together. And the way how we do this, I think that will be, in my opinion, the most important learning from Fabulous, that we can really, yes, in future also to use similar methods also to apply the methodologies to new ideas. But of course, I'm also quite optimistic that we will achieve a quite good performance for the use cases what we have done in the Fabulous, and that we really demonstrate something what was not possible before the project. I mean, that is another aspect. I'm teaching here also at the Erlangen University, and it's really important what we have, that young people get into that field, that they are understanding, getting interested first of all into the field, and then learn what is important in study, and later on then either in academics or in the industry they work in this area. And I think especially in Fabulous, all these new areas about meta services so are exciting. So I always give now in my lecture some examples of that, and that's for me the most important thing. Get the students interested, and then some of them even to get them involved in some small research projects related to that, and then they get somehow attached to the field and see a future career also in nanotechnology. And I think in future we need a lot of well-educated people in this area, in Europe, but also in the complete world.